Thank you. Okay, this is an early morning session, but I'm afraid you're going to have to set your brain to work, because what I'm going to tell you now may seem extremely complicated at first. Pixels are what we use in our day-to-day job as a web developer, but there is something to know about pixels, because a pixel is not a pixel. That is, there are secretly two kinds of pixels, CSS pixels and device pixels. And before you get all upset, oh, what are those, what should I do with them? You already know what they are, you just don't realize it. So don't worry, we start easy. We start with a simple subject. What are CSS pixels? Very simply, they are the pixels you use in your CSS. So if you say width 190 pixels, padding left 20 pixels, whatever, you are using CSS pixels. And the trick is that they are an abstract construct created specifically for us web developers, so we can just write CSS and not worry too much about screens of devices and about zooming factors and that kind of stuff. The important thing to remember about CSS pixels is that their size increases or decreases as the user zooms. Again, you as a web developer don't really have to worry about that beyond a few simple zoom tests, because CSS pixels arrange everything for you. I'm going to give an example of that. Here's the example site I'm going to use throughout this presentation. It's a site we created for a mobile web conference we run in Amsterdam. And of course, this site is properly responsive. However, for the most of this presentation, we're going to pretend that it's not responsive and that it's just a desktop-only website, because that will teach you most. But we haven't started on mobile yet. We're going to start with zooming. We have a menu of 190 pixels, just flat with 190 pixels in the CSS. Nothing special. Now we are going to zoom in. What happens? This. You know that, right? You've done that. The point I want to make here is that the menu is still 190 pixels wide, even though it's wider on the screen. Why is that? Because all of those individual 190 CSS pixels here have all increased in size because you zoom. And of course, if you zoom out, they decrease in size. That is one of the fundamental points of CSS pixels. Their size is not fixed. You, as a user, can change that size. Okay, so what are device pixels? They are the physical pixels on the actual device. Every single device that has a screen has a certain number of device pixels that were created when the hardware was created. They're fixed, you cannot change anything about that. And in general, we web developers don't really worry about them. So the best known example is the iPhone. The old iPhone had 320 device pixels horizontally. And that's what we're seeing here. Basically, if you create a proper mobile website for an old iPhone, one CSS pixel is exactly equal to one device pixel. That's unless you zoom, of course. It can get complicated very quickly, but we're now looking at zoom 100% and a simple website that's optimized for the iPhone. One CSS pixel equals one device pixel on the old iPhone. Then came the new iPhones, right, with the Retina screens, and they suddenly had 640 device pixels. So what happened to the ratio? One CSS pixel is now equal to 2 device pixels width and 2 height, 4 in total. Again, you as a web developer do not have to worry about this. The browser arranges it for you. The browser knows exactly how many pixels there are on the screen, and the browser makes sure that all of these device pixels get their correct color instructions. So you don't have to recreate your site if it suddenly shows up on a new iPhone. So I basically already answered this question. What kind of pixels do you use in your daily work? Almost always CSS pixels, both in CSS and in JavaScript. There's only one real exception to that, and that's screen.width. And screen.width is a very serious problem that I'm going to return to later. Okay, with that in mind, CSS pixels, device pixels, CSS pixels increase or decrease in size as you zoom. With that in mind, we're going to go to the viewports. What is a viewport? To show you, I'm going to give you another example with the example site. The example site has a div container that stretches the entire page, and that div container has a padding left of 34%, which you see here. Now I'm going to teach you a little trick. As soon as you see percentages anywhere in CSS, always ask yourself percentages of what? A percentage by itself is nothing. It has to be a percentage of something. 34% of what is this? You all know the answer. It's 34% of the browser window. Still, you may not be entirely clear on why that is the case. So let's deconstruct it. A general CSS rule is that if you specify a width in percentages, that width is calculated relative to the width of the container. In this case, the div.container is a child of the body. So what we're saying here is, please give the padding left a value of 34% of the width of the body. Okay, so what's the width of the body, right? Another fundamental CSS rule, every block level element by default has a width of 100%, unless, of course, you specify something else in CSS. You know that. Block level elements include the HTML and the body elements. So what we're seeing here is that that 34% is calculated relative to the width of the container, the body, and that body has a width of 100%. 100% of what? Of its container, the HTML element. The HTML element, in turn, also has a width of 100%. 100% of what? And it's now that we arrive at the viewport. The HTML element is the topmost element in our HTML and CSS. We can't go any higher in CSS, but something still has to tell the HTML element, okay, you're this wide. And that's the job of the viewport. The HTML element's width is calculated relative to the viewport. The viewport's also called the initial containing block in CSS. Does anybody here read CSS specifications for fun? No, you? Good, one. Great. Then you know about the initial containing block. The viewport is just another name for that. And its function is to tell the CSS, okay, you have so many pixels, so many CSS pixels, of course. And on desktop, the viewport is equal to the browser window. On mobile, it's a lot more complicated. We're going to talk about that later. Okay. As I said before, when you zoom in, you enlarge CSS pixels. That means that less of them fit on the screen. Right? If you enlarge CSS pixels and the screen has an equal width, less of them fit. So the viewport becomes smaller. That's something you have to realize. So again, the example side, here the viewport is about 720 pixels wide. And that's because of the way I took the screenshot. It's nothing fundamental. Now we zoom in, and the viewport becomes about 580 pixels wide, because all the CSS pixels stretch up, less of them fit in the screen, so the viewport becomes smaller. There's an inverse relationship between zoom factor and viewport. Okay, that's about desktop. As I said, on mobile, it's a lot more complicated. In order to understand why it's more complicated, you have to put yourself in the shoes of a mobile browser vendor, say 6, 7, 8 years ago. Apple introduced the first iPhone, Google was working on Android, Nokia and BlackBerry started to understand that their browser had to be able to show real websites. But the problem back then was that there were no mobile optimized websites. Nobody had ever yet heard of the Meta viewport, nobody bothered to test on mobile, so all we had was desktop sites. Still, those early mobile browsers had to show something decent, right? If you say, hi, I'm a browser and I work on your phone, you as a consumer expect to be able to see a normal website. The problem here is that if we would literally copy the desktop definition of the viewport to mobile, we would run into problems because many sites would be squeezed to death. I'll show you. Oh, I gave away the clue. Here is the site on mobile, and the next, the site on desktop. The next slide is going to show you that site on a mobile phone, and we're going to pretend that that mobile phone uses exactly the same viewport definition as the desktop. And you get this. Technically, this is correct. It follows all the CSS rules, but it's hideously ugly. This is what mobile browser vendors wanted to avoid. This is what they definitely did not want to have. So they could not literally copy the desktop viewport definition to the mobile phone. They had to change something. And they did so by deciding that by default, the viewport would be between 768 and 1024 pixels wide, depending on the device and the browser, with the most common value being 980 pixels iPhone. So that means that a desktop website will show up decently on a mobile phone. It's not great. It's still a desktop website being viewed on a mobile phone. But it's the best they could do. They said, okay, dear website, you have 768 to 1024 pixels to show yourself in. And that usually means that the CSS works kind of okay. And you kind of see the site that you're expecting. This is what we call the layout viewport. And of the three mobile viewports, it's by far the most important one. The layout viewport's purpose is to constrain your CSS layout. To say, okay, this CSS layout in total has so many pixels. Okay, responsive design at its basics is the art of overriding the default width of the layout viewport. Because if we create a mobile site, we don't want a 980 pixels viewport. We want 320 or 360 or something like that. We'll get back to that. So this is the layout viewport. Again, we're pretending that this site is not mobile optimized in any way. It will be shown roughly like this. It will be far too wide for the screen. The viewport is now far wider than the screen, but that is deliberate. You can't do anything else as a mobile browser vendor. Still, we need to say something about the actual window width as well. We need to be able to tell how much the user is currently seeing, partly because there are certain CSS declarations, such as position fixed, that assume that they work together with what the user is seeing. A position fixed layer should stay fixed no matter how the user scrolls or zooms. And that means we need a second viewport called the visual viewport, which defines what the user is currently seeing. And that's this. Right? So on desktop, the viewport is the browser window, and it secretly has two functions, but you never think about that. It constrains your CSS layout, and it defines what the user is seeing. And on mobile, those two have been pulled apart. Compare it to this. You have a nice image, which is the layout viewport, and it looks good. However, on a mobile phone, you are not seeing the entire image, but you're peeping through a keyhole. That's the visual viewport. Fortunately for you, you can move the visual viewport and enlarge it if you want to. That is kind of how the two viewports interact on mobile. And you're already doing this. If you have ever looked at a website on a mobile phone, you have already used the layout and the visual viewport as they were intended. Brief detour to JavaScript. You can read out the dimensions of the layout viewport and the visual viewport if you want to. Layout viewport is document element .client width and client height. And it's occasionally useful to use JavaScript instead of CSS media queries. For instance, when you want to show a Twitter or a Facebook widget only when the screen, when the viewport is, I don't know, 600 pixels or larger or something, you could write a media query for that. But the best you would be able to do is set it to display none in CSS. And if you set something to display none, most browsers still download the assets, right? The images and the scripts and the stuff. And that's exactly what we don't want on a mobile connection. So in these cases, it's better to use JavaScript to read out the layout viewport size and to say, okay, if that's larger than 600 pixels, then we start downloading and initializing the Twitter or Facebook widget or whatever. So you will occasionally use this. And this works in all browsers. I tested everything I tell you today in 50 browsers. Visual viewport is window inner width and window inner height. And that doesn't quite work in all browsers. And the biggest problem is Android WebKit 2, the old default browsers of Android 2 phones. They're not terribly important anymore, but occasionally you will encounter one on your site. Fortunately, you do not really need to read out the visual viewport size most of the time. But if you do need, it's there. Okay. We have split the desktop viewport into two, layout viewport a visual viewport, but on mobile there's a third viewport, one that doesn't exist on the desktop at all, and it's what I call the ideal viewport. Now, what is the ideal viewport? If you load a desktop optimized website on a mobile phone, what you get in practice is this. Mobile phones have to decide, okay, this desktop website is far too wide for my screen, but I still have to show it somehow. So, okay, we're going to zoom out as much as possible. This is the least bad option for showing a desktop website, because the font is unreadable, but at least the user has a kind of an overview over the site and can decide, okay, I want to zoom in on the navigation or the main text or the speaker photos or whatever. So it kind of makes sense. Still, it's not a mobile user experience. What we want is to give websites the perfect width for the device so that the user does not have to zoom and pan and the text is readable. Right? That is a mobile optimized site. You open the site on your mobile phone and bang, it looks good immediately. That's what we want. That is the job of the ideal viewport. The ideal viewport has the ideal size for a website on the specific device it runs on. And on the old iPhone, of course, that was 320 by 480. On most Android phones, it's more like 360 by 720. Essentially, the ideal viewport is just a width and a height, buried somewhere deep into the browser, waiting until you, as a web developer, call upon it. And when you do, you get a proper mobile site. The ideal viewport alone is not enough. You also have to say, okay, how wide is this ideal viewport? And then adjust your CSS with media queries. We'll get back to media queries later. But this is the necessary first step. This is a weird ideal viewport. I'm showing the BlackBerry Z10 as an example device here in this presentation for two reasons. First of all, to remind you that there's more than just iOS and Android. And secondly, because it has a weird viewport. 342 by 570. If you're used to the 320 by 480 of the old iPhone or the 320 by 568 of the new iPhone, these are weird values. My point here is that they are not wrong. They're just different. These values actually make sense on the BlackBerry Z10. Again, I tested this in 50 browsers, and just about all of them had an ideal viewport size that made sense for the device they run on. Still, okay, if you find an ideal viewport size of 342, it's weird. Secretly, the ideal viewport has a second function, and that is covering up device differences for you. The old iPhone, the iPhone 3, had 320 device pixels and an ideal viewport of also 320. That's not a coincidence, of course. They tested this at Apple. Then along came the new Retina iPhone with 640 device pixels, but the ideal viewport remained at 320. There's two reasons for that. First of all, 320 is genuinely the best viewport for the physical iPhone when you hold it in your hand and want to show a site. Secondly, if they would have changed the ideal viewport, a lot of iPhone optimized sites would have broken because they expect 320, they get 640, and it looks horrible. So what the ideal viewport is doing here is covering up the differences between devices for you. If you say, okay, give me the ideal viewport on an iPhone, it will be 320, and you don't care if it's a Retina one or not. This is even more important on Android, because there's only a few iPhones, but there's thousands and thousands of Android devices. Did you ever test on an obscure Chinese Android device? You should. It's fun, especially when the interface is in Chinese. There's thousands of Android devices. You cannot possibly test your site on all of them. But the ideal viewport helps you a lot here, because it turns out that most Android devices have one of three ideal viewports: 320, 360, or 400. With 400 being the really big Samsung Galaxy Notes, 360 being the average Android device, and 320 being the smaller ones. So if you test your website on some Androids and also make sure that the design looks good on 320, 360, and 400, you can be reasonably certain that your design will show up decently, at least, in the vast majority of Android devices. So again, here the ideal viewport helps you ignore device differences. JavaScript, can we read out the ideal viewport size? Unfortunately, we cannot. Screen.width and screen.height give the dimensions of the ideal viewports in some browsers, but not all. Other browsers say that screen.width and screen.height are the number of device pixels on the screen. And you don't know what you're going to get. So you cannot read out the ideal viewport, but it's even worse. Because of this, all your nice resolution analytics you get from your Google Analytics or your Standcard or whatever are completely worthless. Because all these services read out the resolution by reading out screen.width and screen.height, but you don't know which definition you're getting. Right? You see an Android WebKit on a 1280 by 1920 device, and you see a Chrome on a 360 by 720 device. It's actually the same device, just a different interpretation of screen.width and screen.height. So do not trust your resolution analytics. They're worthless. Fun, isn't it? Okay, so those are the three viewports. Layout viewport, which constrains your CSS layout. Visual viewport, which tells you how much the user is currently seeing. Ideal viewport, the ideal size for a website on the specific device. What we want to do is set the layout viewport width to the ideal viewport width, right? Then the website has the optimum width for the device. How do you do that? It will not be a surprise by the meta viewport. This, right? You have all used this, but I hope you're starting to understand why this works as it works. If you say width equals device width, you tell the browser to take the ideal viewport width and set the layout viewport width to that value. And as a result, your site gets the optimum width for the device it runs on. You do not need to know which value that is. It can be anything. So, by default, without you doing anything, the layout viewport is between 768 and 1024, so that a mobile browser can also accommodate desktop websites. Using the meta viewport tags allows you to change the width of the layout viewport. You can use a pixel value if you want to. Width equals 400, for instance, sets the layout viewport to 400 pixels wide. How many of you did not know this? A few. Okay. You can. It's just not very useful. Because in 95% of the cases, you use the device width keyword, which tells the browser, please use the ideal viewport. And the browser does, and you're starting to create a responsive design. So I'm kind of assuming that all this does not really come as a surprise to you. You may not know the exact terminology, but you already had an idea of what width equals device width is doing. I'm hoping that the next slide will be a surprise to you, because there's a second way of doing exactly the same, and that's this. Initial scale equals 1. Now, what does this mean? Scale is Apple talk for zoom. So what you tell the browser here is to zoom into the value 1, which is 100%. You remember the question? 100% of what? 100% of the visual viewport? No. Turns out not to be. 100% of the layout viewport maybe, should make sense, but that's not the answer either. It turns out that it's 100% of the ideal viewport, even if you don't actually use that ideal viewport. That's weird, but it gets weirder. Because the second thing initial scale equals 1 does is, again, setting the layout viewport to the width of the ideal viewport. Exactly the same as width equals device width does. Again, this works in every browser, because it's how Apple created the meta viewport tag, and everybody else copied that. It gets even weirder when you use a different value. Initial scale equals 2, for instance. That means please set the zoom factor to 200 pixels. And on an old iPhone, which normally has 320, that would mean you have a visual viewport of only 160 pixels, right? Because the CSS pixels now stretch up to twice the width and twice the height. So twice as few fit in the screen, so 160 pixels. That works, but most browsers also set the layout viewport width to half the ideal viewport width now. If you think that makes sense, please come and talk to me afterwards and explain it, because I do not understand it. I can just assure you that it works like this. I've been thinking about this a lot, and I just don't get it. Okay, now we get to the fun part. The fun part of doing browser compatibility research is to try to mess up browsers. When I had found out all what I told you just now, I decided to give the browser conflicting instructions. And I did this. Dear browser, please set the layout viewport width to 400. No, wait. Please set it to the ideal viewport width. When I wrote this test, I expected browsers to be all over the place. One to do this, the other to do that, some to get totally confused and just show gibberish, etc., etc., etc. You know, a nice row in my compatibility tables with a lot of colors and stuff and all kinds of different stuff going on. Turns out that that's not the case. It turns out that all browsers do exactly the same. They take the highest value of the two. So what I'm basically saying here is, dear browser, please set the layout viewport width to either 400 pixels or the ideal viewport width, whichever of the two is larger. And if the device orientation changes, it's recalculated. So again, old iPhone, 320 by 480. In portrait mode, the ideal viewport is 320. Largest of 400 and 320 is 400. So the layout viewport is now 400. Then we switch orientation to landscape. This becomes 480. The largest of 400 and 480 is 480, so now it switches to 480, from 400 to 480. Again, this works on all browsers, and what we have found now is a way of setting a minimum width to the layout viewport. I discovered this in October last year, and ever since I've been wondering, okay, this is cool, but this is also useful. I have not yet found a practical use for this. I'm giving this presentation a lot this year, and I'm asking all my audiences, if you do know of a practical use case for a minimum width of the layout viewport, please come and tell me. So far, nobody has done so. If by the end of the year nobody has done so, I'm going to assume that this is a nice technical trick that has no practical application whatsoever. But if you want it, you can do it. It works. Okay, Safari problems. Width equals device width. Safari always takes the portrait width. 320 on the iPhone, 768 on the iPad. Even if you go to landscape mode. Sometimes that's what you want. Sometimes it's useful to have only one layout for your website, but most of the time I get pretty annoyed because if text is too small or the lines are too big, I just switch to landscape mode expecting to see bigger lines. You don't in Safari. This is a deliberate thing by Apple. I'm not totally sure why they did it. I think it partly has to do with preserving battery life and processor time, because if you switch the orientation and the layout viewport changes, the rendering of the entire page has to be recalculated. Never forget that. So I think that Apple said, okay, we don't want to do that. On the other hand, all other browsers do it nowadays. Can we solve this? Actually, yes, we can. This. 320, 480. Now it works. Don't ask me why. I don't understand, but this is how it works. It works in Safari. It works in all other browsers, so that's cool. Except in IE10, which has exactly the opposite bug. Here, it stays at 320. If you use width equals device width, it switches between 320 and 480, or whatever the values are. So what's the solution to this problem? Use them both. Because initial scale works in Safari, device width works in IE10, both work in all other browsers. And so here we get the perfect meta viewport. Width equals device width, comma, initial scale equals 1. If you use this in all your projects, you're avoiding a lot of problems, including some that I'm not going to talk about in this presentation. So do this. Next problem. It's a bit weird what we're doing here. What we're saying here is something totally fundamental to CSS, right? The width of the layout viewport. We set that with an HTML tag and not in CSS. That's why Opera years ago proposed to use this syntax instead in your CSS. They implemented it in their old Presto rendering engine, but a year and a half ago they went over to Blink and lost this. Right now, only IE uses this syntax and prefixed at that. So this is the proper IE syntax. Now it gets complicated, IE. The meta viewport tag that we just discussed just now works on Windows Phone, but not on Windows 8 tablets, such as the Microsoft Surface. However, this one does. That's cool. Secondly, on a Windows Phone, the meta viewport tag gives a different value than this. And you may think, oh my God, there goes Microsoft again. But it's actually our fault. What Microsoft has done is say, okay, if you use the meta viewport tag, the HTML construct, we set the layout viewport to 320 pixels. Why? Because iPhone. Because we web developers weren't paying attention to any kind of other phones and just said, okay, if it's 320, basically 320 is the only resolution that exists, the only layout viewport width that exists. And we didn't think any further. However, most Windows phones are slightly wider than an iPhone, so it would make sense to make the ideal viewport slightly larger. And on the particular Windows Phone I test on, this gives an ideal viewport of 364, which fits the device better, which is actually, from a purely design standpoint, better than the 320 of the meta viewport tag. So my advice is to use this as well. This construct overrides the meta viewport tag in IE, so if you use both, this one gets precedence, which leads to the even perfecter meta viewports, this one. This goes in your CSS, this goes in your HTML, it works. And on Windows Phone, in IE, you now get an ideal viewport that's actually suited to the device instead of to the iPhone. Right, media queries. You've all seen a media query, right? I don't have to explain this, I hope. Has anybody never seen this before? It's completely new to anyone? Good. What is a media query? There's two important media queries I want to discuss today, width and device width. Width is the one you want. If you are using device width in your website, I'm very sorry to tell you that you are doing it wrong. You should change to width. Why is that? On the desktop, device width tells you how wide the device is. Do you want to know this? No, you don't care. What you want to know is the width of the browser window. Device width doesn't give you that. On mobile, device width at first sight seems much more interesting because it gives the width of the device, and that is something you do want to know. However, there's a serious problem. On all 50 browsers I tested, the device width media query uses exactly the same value as screen.width. And we already saw that screen.width has two meanings, the ideal viewport or the number of device pixels, and you don't know which one you're going to get. So if you're using device width, it will work in some browsers but not in others. And that's not what you want. Instead, you want width. Width gives you the size of the layout viewport. On desktop, that's of course equal to the browser window. And on mobile, that's equal to the calculated layout viewport. Here again, we have a desktop optimized site on mobile without a meta viewport tag. It's this, and later on we will see an example of a proper responsive mobile site. Width gives the width of the layout viewport, which is what you want to know, and which works. Always, everywhere, no exceptions. And then you get this. You constrain the layout viewport to the size of the ideal viewport so that the site now has the ideal width for the device it runs on. Then you use the width media query to figure out how wide that layout viewport actually is and switch from one column to two column or make your images smaller or whatever you want to do in your CSS. That is how responsive design works. I'm kind of assuming you already knew most of this, but I'm hoping I taught you why it works, not just how. One more thing about media queries. Please always use min or max width. Never use width. You want to establish a range. You want to say up to 600 pixels, I want to do this. From 320 to 480 pixels, I want to do that. Min width, max width. Remember the 342 of the BlackBerry Z10? The BlackBerry browser is an absolutely fine browser. There's nothing wrong with it. But you have to make sure that it can use its own 342 pixel ideal viewport. There's more than just the iPhone. Okay, so this is responsive design, but we would like to take it one step further, at least I would. I would like to make responsive design respond to the physical width of the device as well. For instance, setting a min width of 25 millimeters, which means 25 real live millimeters. I'm here to tell you that you cannot. It's impossible to do so. And in order to understand why, we have to take a brief look at CSS units. With 25 millimeters does not mean 25 real life millimeters. Instead, it means, by definition, 94.488 pixels in all browsers. I tested this. In a sense, centimeters, millimeters, and inches are fake units because they have nothing to do with the real world. Instead, in CSS, 1 inch is defined as 96 pixels. I think it's actually in the CSS specification. It certainly works like that in the browsers. If you don't believe me, create an element 96 pixels wide, create an element of 1 inch wide. They are have exactly the same width. Even better, when you zoom in, CSS pixels become larger, right? And your inch becomes larger as well. So they have nothing to do with the real world. Here are the definitions. I'm going to put this slide online so you can look at it later. I used to think this was a pretty bad idea. I used to think that it would be totally cool to be able to respond to real-life sizes, but I changed my mind. Not for a fundamental design reason, but for purely technical reasons. Because if an element would have a width of 25 real-world millimeters, that would mean that the browser would have to recalculate that element every single time the user zooms. And zooming happens a lot on mobile. So the battery would drain, the processor would be overheating, and the experience would deteriorate. This is why we will never have real-life millimeters, at least on phones and probably not on desktop either. One last show of hope. Maybe we could use resolution to figure out something useful about the physical device. No. Resolution does not mean what you think it means. We have this. This works in all browsers. Window device pixel ratio, right? That's for responsive images and stuff to figure out if you're on a retina screen or not. You can do the same with media queries, but you need 2. One for the WebKit-based browsers and one for all other browsers. Eventually, this is going to be supported by the WebKit-based browsers as well. The problem is the name. Resolution is fundamentally the wrong name for this metric because it has nothing to do with what we think of as resolution. Because what is a device pixel ratio? I tested this in 50 browsers, and it turns out that the answer is the ratio of the screen size in device pixels and the ideal viewport size. That's it. That's what it means. Example, iPhone 3G. 320 device pixels, ideal viewport of 320, device pixel ratio equals 1. iPhone 4S, 640 device pixels, but still an ideal viewport of 320, which gives a device pixel ratio of 2. Next example, the Samsung Galaxy Pocket, which is a fairly cheap, fairly crappy Android 2 device I own. If you're serious about mobile browser testing, I advise you to buy a fairly cheap, fairly crappy Android device, because that will teach you a lot about what can go wrong on mobile phones. Because it's fairly cheap and fairly crappy and fairly small, it has only 240 device pixels. Still, the ideal viewport of the default browser is still 320, which gives us a device pixel ratio of 0.75. Incidentally, this is the Android WebKit default browser. On the same device, I've installed Opera Mobile, and it has an ideal viewport of 240, and therefore a device pixel ratio of 1. I think Opera's right here. I think we shouldn't try to do this on a crappy device. this also shows that device pixel ratio is dependent on both the browser and the device. It's fun. Then again, you can just read that out and be done with it. I mean, it's not really difficult. I just want to explain to you how it works. BlackBerry Z10. 768 device pixels, ideal viewport of 342, which gives us this device pixel ratio. This is weird, but not wrong. It's just math, right? We just divide these two and we get this. Still, this shows you that you shouldn't say if window.device pixel ratio equals 2. You should, again, just like with the media queries, specify a range. If it's 1.5 or larger, something like that. We have reached the end of my presentation. If you want more information, I've written a book. In fact, I think the ebook is going to be released either today or early next week. And you're all required to buy a copy because I need money. It has an entire chapter on what I told you just now, so you can read it. And with that, I'm going to end this presentation. These slides will be online later today, so you can look at it in peace. Do you have time for questions? Yes. I'll take 1 or 2 questions. Yes. Wait for the microphone, please.
How do you test on 50 mobile devices?
How do I test on 50 mobile devices? I did not say devices, I said browsers. I have only 35 devices. I test in batches. That is, yeah, you know, I'm a compatibility tester and not a website maker, so it's slightly different for you. But what I do is I create a new test. I test it roughly, you know, on an iPhone and an Android and a BlackBerry and a Windows Phone just to see if the test itself is working properly. When it does, I say, okay, now I'm going to start my real test. I've got a list of browsers. I will show you that list. It's online. Go away. No. Here it is. No, here's not. Oh yeah, the bloody Wi-Fi. Well, whatever. I have a list of Wi-Fi, of browsers, of things, of important things that I use. And then I go through that list. I start with iOS, iPhone, iPad, test them, make notes. Then I switch to Android 2, of which I have 2 or 3 devices. Test it, make notes. Android 4, I have 8 Android 4 devices. That's interesting because there's a lot of differences between the various Android WebKits. And so I go through my list in order and I test in batches. And if you have to test on a lot of mobile browsers, I advise you to do the same. First, sit down, make a list. Okay, which browsers do I want to test in? Take 2 hours to make that list, 3 hours if you must, because it's really going to help you later on. You are going to create that list and then group similar browsers. The Android WebKits, Chrome and Opera and Firefox, the easy browsers, BlackBerry IE, Opera Mini, that kind of stuff. Once you actually start creating the website, you do roughly like I do. You take 1 iPhone, 1 Android, 1 BlackBerry, 1 Windows Phone, 1 something else, and you test roughly. Basically, what you're trying to do now is not get it pixel perfect, but figuring out if your approach is going to work at all. If you see serious problems in this first test, your approach is wrong and you should probably change it. If it works okay across devices, then you can go to the detailed test. Then you take your list and go through it in order. Start with iOS. It's actually better to start with Android WebKit, the old Android default browser, because you can expect a lot of problems there. So you go through the list, you test an Android WebKit, you solve the problems, you go back to the general batch, you test it again, you go back to Android WebKit, test it again, okay. Now you go to the next batch, which is likely IE and Opera Mini, because these are difficult browsers as well, and you repeat that until you reach the end of the batch. For me, it's slightly different because I do compatibility tests. I don't have to retest. If something goes wrong, I make a note and I go on. But that is how I test browsers. And yes, this takes a lot of time. It will take you at least 3 times as much time as testing on desktop browsers. And the first time you do it, 5 or 6 times as much. Because you have to make sure that the mobile phones are charged. This sounds weird, but you can actually forget to charge a mobile phone. Right? Okay, now I'm going to test the BlackBerry. Here's the BlackBerry. Oh, damn, it's not charged. Oh, okay, I'll wait for 10 minutes. You have to make sure that the phone's connected to the Wi-Fi. In general, that is not such a huge problem anymore, but back in 2009 when I started, I once spent an entire day trying to get 2 phones connected to the Wi-Fi. It just didn't bloody work. Well, one of them was Windows Mobile, so there. What was I saying? I was saying something interesting. Anyway, it takes a lot of bloody time, and there's nothing you can do about it. You have to eat that time. You have to do it. Time for one more question? One more. Who? Yeah. Wait for the microphone, please.
Hey, so just to bump into that question, do you know Ghost Labs, for example?
Ghost Lab, yes, I do know it. I have never used it. Ghost Lab is, correct me if I'm wrong, it's a script that you include in your page, and then you can make sure that your mobile phones follow whatever you do in your desktop browser, so that they do exactly the same as as the desktop browser does, which is very useful for long tests. I totally advise you to use it, but I myself do not use it, again, because I'm doing compatibility tests. And I may not include an extra JavaScript in that compatibility tests. Because in theory, it could be that a JavaScript interferes with my testing. But you should definitely use it, because it's very useful. Well, that's it for now. Thank you so much for your attention. I hope you learned something.